Hey everyone, I'm Charles Judd, and in this video, we're going to take a look at configuring an MPLS Layer 3 VPN so that we can examine VRF-aware routing. There's lots of moving pieces involved, so let's dive in and take a look at our topology first. So here is our topology. We have a fairly simple representation of a provider network here. This is essentially a small snippet of what we would see within an MPLS provider network. You can see that in the center we have an MPLS core, and at the edges of that core we have two provider edge routers labeled PE1 and PE2. These, of course, sit at the edge of the MPLS core network and connect out to our customer sites as we see here, and those all lie within Autonomous System 65,000. We also have four customer edge routers labeled CEA1, CEA2, CEB1, and CEB2. So each of our provider edge routers has a customer A site and a customer B site, each individual customer having two sites in this network. We're going to configure an MPLS Layer 3 VPN for VRF-aware routing, where we'll implement separate VRFs for each of these customers. Let's start on our PE1 router, our provider edge router, and let's say show MPLS interfaces, and you'll notice that we have our gig 0/2 interface configured for MPLS, which is connected into our provider backbone or our MPLS core. If we say show MPLS LDP neighbor, you can see we do have a valid neighborship as we would expect. We can also say show IP OSPF neighbor, and we're also going to see an OSPF adjacency with one of those MPLS core routers. So this tells us that we have OSPF configured as an IGP on our provider network, and we have MPLS configured as well. So with our provider edge devices configured for MPLS and with a valid IGP in place in our provider network, we're ready to begin creating and assigning our customer VRFs. Again, these are going to be configured on the PE routers, and the interfaces connecting to our customer sites will be assigned into those VRFs, which our topology on the screen indicates is going to be gig 0/0 and 0/1 on each of those routers. So still on PE1 on our first provider edge router, let's go ahead and create our VRFs. Let's go under global configuration mode, and we can say IP VRF followed by the name that we want this VRF to have. So I'm going to name our customer A VRF simply cust-A. The next thing we need to do is to indicate a route distinguisher. A route distinguisher is a way that we distinguish one VRF from another, and this very simply is a unique number that's going to be prepended to each route within the VRF so that ownership can be identified. So in our case, we're going to create a couple of different route distinguishers, one to identify customer A VRF traffic and the other for customer B VRF traffic. We do that by saying RD followed by the actual route distinguisher. And if we look at contextual help, we can see the format options for that. Now, whatever you choose, it really doesn't matter. It's actually just up to your own preference because this is mostly cosmetic. I'm going to use the first format that we see indicated here, which is a 2-byte autonomous system number followed by a 4-byte custom identifier value. So in my case, I'm going to make the route distinguisher for the customer AVRF 65,000:1. We also need to specify a route target, which is the way that we indicate which routes are going to be imported or exported with a VRF. So let's say route-target. And if we look at contextual help, you can see that we have the options listed for import, export, or for both. So we can choose which one of these we want specifically. In my case, I'm just going to use the both keyword to take care of both importing and exporting prefixes, and I'm going to give this a similarly formatted identifier here. Now you can make this exactly the same as your route distinguisher value, and for simplicity I typically do that, but just know that it doesn't have to be the same. You can give that a different identifier if you choose to do so. Again, in my case, I'm going to keep it the same, 65,000:1. So let's also create a VRF for customer B as well. Let's say IP VRF and I'll name that cust-b. I want to create a route distinguisher. This time I'll make that 65,000:2. Again, we want that to be unique from our customer A route distinguisher. And then let's say route-target both. Again, I'm going to use the same identifier, 65,000:2. So with that in place, let's go to our other provider edge router, PE2. And we're going to do something fairly similar here. We want to create our VRFs on this router. We'll do that a little bit quicker this time since we've already discussed the reasoning behind what we're doing. So we'll say IP VRF customer A, route distinguisher, 65,000:1, route target both, 65,000:1. Let's also create a VRF for customer B. Our route distinguisher, 65,000:2, route target, both, 65,000:2. So now we have our VRFs created. The next thing we need to do is to assign the customer-facing interfaces into each VRF. So back on PE1, let's go under interface gig 0/0, which you can see in our topology is facing the customer A network on this router, the CE-A1 router. And let's say IP VRF forwarding, and we will follow that with the name of the VRF, which in our case is cust-A. Now notice when we do this, we have a message saying that the interface IP address has been removed. This is the expected behavior, so we do need to reapply the IP address to this interface. Now, I'll also say that there are some versions of iOS that do not have this warning message. So this is something you want to especially be aware of if you're using an older iOS version. In any event, let's reconfigure that IP address. Let's say IP address, and you can see from the topology that should be 10.0.0.2 with a /30 subnet mask. So with that back in place, let's do the same now for our customer B VRF. We want to do that under interface gig 0/1, which is connecting out to our customer B site. And we'll say IP VRF cust-b. And actually, I left out the forwarding command, IP VRF forwarding cust-b. And actually, before I do that, I have to go back because that actually placed me under VRF configuration mode. I don't want to do that. So we'll go under interface gig 0/1. We'll say IP VRF forwarding customer B. It's going to remove our IP address. So let's put that back in place. Say IP address. And this needs to be 20.0.0.2 with a /30 subnet mask. Let's go over to PE2 and do the same thing. Let's go under interface gig 0/0, IP VRF forwarding customer A. It's going to remove our IP address, so we'll put that back in place. IP address 30.0.0.2 /30 subnet mask. And now interface gig 0/1, IP VRF forwarding customer B. Reconfigure our IP address 40.0.0.2 with a /30 subnet mask. If we break out of here and we say show IP VRF interfaces, we can verify which interfaces we've added into each VRF instance. You see that interface gig 0/0 is associated with customer A and 0/1 is associated with the customer B VRF. Let's do the same on PE1, show IP VRF interfaces, and gig 0/0 is with customer A, 0/1 is with customer B. So that's good. Now, one thing I'll point out is that if we try to ping one of our routers, so for example, we should be able to ping the CE-A1 router at 10.0.0.1. But if we try to do that, that's going to fail. And that's because we've added these interfaces into our VRFs. So we'll have to explicitly state which VRF we want to use when we're trying to ping a device. So we would need to say ping VRF, the name of the VRF, which is customer-A, 10.0.0.1. And this time we do get a success message. Now it's time to take care of our multi-protocol BGP configuration. And that's going to allow us to advertise our VRF routes between our two provider edge routers. So MP-BGP is only going to run on the PE routers themselves. The provider routers in the MPLS core, they'll be using their own IGP and MPLS to take care of all of that traffic there. And likewise, the customer edge routers will also have no knowledge of routes outside of their own VRF. So still here on PE1, we clear off a little bit of space. And this is going to be a fairly basic MP-BGP configuration. So let's go under global configuration mode. We'll go under our BGP autonomous system number, which is 65,000, and we'll say neighbor. And you can see in the topology, the loopback address on the PE2 router is 3.3.3.3. So we'll use that. We'll say remote-AS 65,000. And I'm also going to say neighbor 3.3.3.3 update-source to loopback 0 to set the source of my packets as the loopback interface. Now, in order to carry our prefixes, remember now we have the route distinguisher prepended to the front of those prefixes, as we discussed earlier. So in order to do that, we need to use an address family, and specifically a VPN version 4 address family, in order to carry these longer than normal routes. So let's say address-family, and the option that we want to use under here is VPN version 4, which will support our VRF route distinguishers and IP prefixes. When we hit enter, we're now under address family configuration mode. So let's activate our neighbor by saying neighbor 3.3.3.3 activate. Now let's go to PE2 and finish up this configuration on that side. Clear off a little bit of space. We'll go under our BGP autonomous system number 65,000. We'll say neighbor. You can see the loopback for PE1 is 2.2.2.2. Remote-AS 65,000. Neighbor 2.2.2.2. Update-source to loopback 0. You can see that we have a BGP adjacency. Neighbor 2.2.2.2 is up, so that's a good sign. Let's say address-family VPN version 4. And now we want to say neighbor 2.2.2.2 activate. We do see our BGP adjacency reset because of the address family configuration, but we now see that we are back into the upstate, so that's good. We have an adjacency formed. If we break out of here, a little different than our normal BGP show command, we want to say show BGP VPN version 4 unicast all summary. And here we see our neighborship with the 2.2.2 router, which is PE1. Next, we want to configure the route exchange between our customer edge routers and our provider edge routers. This is going to allow us to exchange routes between the customer and the provider. Now, we could use BGP, we could use RIP, EIGRP, whatever we prefer between the customer and provider edge devices. In this case, I'm just going to use OSPF to exchange those routes. So first, let's go to CE-A1. That's our first customer A site. And let's do a quick show run, pipe 2 section, router, OSPF. I do want to show you what we currently have in place on all of our customer routers. And here we're going to see that we have OSPF process 1, and we're advertising the local loopback address into OSPF. We're also advertising the network that is attached to the PE router, and we're advertising our host subnet, the 172.16.1.0/24 network. So now let's configure OSPF on our provider edge routers. Back on PE1, let's break out of here and clear off a little room. And we want to create an OSPF process for each of our customer VRFs that we're using on this router. Remember, we already have process ID 1 running on our provider edge router as the IGP for the provider network. And we can verify this by saying show run pipe 2 section router OSPF. And this is going to show us that we have OSPF process 1 running. Again, this is being used as an IGP for our provider network. So when we create these 2 new OSPF processes for our VRFs, I want to start with number 2 instead. So let me go under global configuration mode, and I want to say router OSPF process ID 2. And if we look at contextual help, you'll see that we can associate this with a particular VRF. So let's do that. Let's say VRF, and I'll do customer A first. And now let's add the network that's connecting us to our customer A edge router. Let's say network 10.0.0.0, a 0.0.0.3 wildcard mask. And we'll add that into area 0. And we should see an adjacency form for this very shortly. We do see that, so that's another good sign. Now let's create our other OSPF process for the customer B VRF. Let's say router OSPF 3 VRF customer B, and we want to say network 20.0.0.0. Same wildcard mask, also into area 0. And we should see a second adjacency form here as well shortly. And we did just see that happen, so that's great. Let's go to our PE2 router, our other provider edge router, and we're going to do basically the same thing. Let's go under global configuration mode. We'll say router OSPF 2 VRF customer A. We want to say network 30.0.0.0 with a 0.0.0.3 wildcard mask into area 0. Now we'll create our OSPF 3 process for VRF customer B, network 40.0.0.0, the /30 wildcard mask, and we'll say area 0. We already saw one OSPF adjacency form. We should see the second one soon, and we did just see that in our console. So we're almost there. Our MPLS backbone is up and running. Our customer edge routers are sending routes to the provider edge routers within separate VRFs. So now the last thing we need to do is to redistribute this into BGP. Once we do that, this is going to allow our customer edge routes in each VRF to be transported across the provider network between our 2 provider sites. In other words, between PE1 and PE2. If you're familiar with route redistribution, this is going to be really straightforward. So let's go back to our PE1 router, and we'll clear off a little space. And let's first run the show BGP VPN v4 unicast VRF cust-a. And you'll notice this output is blank. If we do that for customer B, we also have a blank output. This means we don't have any VPN version for routes at the moment. Once we redistribute OSPF, then we should have some routes listed in this output. So let's go under global configuration mode, router, BGP 65,000. And again, a really simple redistribute process that we're going to use here. Let's go under address family, IP version 4, VRF, customer A, and we'll say redistribute OSPF. And remember, our customer A VRF is associated with OSPF process 2. So we'll hit enter for that, and we'll do the exact same thing for customer B, and we'll redistribute OSPF process 3. Now let's break out of here and let's run that show command that we used earlier. Now you'll notice for customer B, we do have some routes learned from the customer sites. Let's do that for customer A as well. And we're also seeing routes there. That's great. We are only seeing our CEA1 routes and our CEB1 routes. Of course, we haven't configured redistribution on the other side yet. So let's go over and do that. And then we should see routes from all of our customer sites. That should give us a complete look at the network. So let's clear off a little space here. We'll go under global configuration mode on PE2, router BGP 65,000, address -family, IP version 4, VRF customer A, and we'll redistribute OSPF process 2 into that. And for the VRF customer B address family, we'll redistribute OSPF process 3. Let's break out of here And let's run that same show command that we used on PE1, show IP BGP VPN version 4, VRF, customer A. And now we're seeing networks from both of our customer A sites, CEA1 and CEA2. If we do the same for customer B, we should see a similar story, and we do. We see routes from both of our customer B sites. So that's exactly what we want to see. We also want to redistribute these in the opposite direction as well. We want to redistribute from BGP into the customer OSPF processes. So back on PE1, let's go under router OSPF 2, which is associated with customer A, and we'll say redistribute BGP 65,000 subnets into that. And then router OSPF 3, which is associated with customer B, and we'll do the same thing for that. Back on PE2, we'll do the exact same thing. Router OSPF 2, redistribute BGP 65,000 subnets. For OSPF 3, we'll redistribute there as well. Okay, now we've come a long, long way. That's a lot of commands, a lot of things going on. Let's confirm everything. We should now have end-to-end connectivity between our customer edge routers. So let's go on CEA1. We'll clear off a little space. So theoretically, we should be able to ping the other customer A site, CEA2, at 6.6.6.6. That's the loopback address on that router. If we try to ping that, we are successful. That works, so that's great. Now, if we say show IP route, it looks as though we have a complete routing table for our customer A VRF. We see both the 172.16.1.0/24 network represented and the 2.0/24 network represented as well. One last thing, let's run a trace route. So let's trace route to our other customer A site, and we'll take a look at the path that we're taking through the network. You can see our first hop is 10.0.0.2, which is of course our PE1 router. After that, we notice some MPLS labels that are being used to cross our provider network. So first, we go over 50.0.0.1, which is going into our MPLS core. Then we see the 30.0.0.2 address, which is PE2. And then we reach our CEA2 router's loopback address over the gig 0/0 interface, which has the IP address of 30.0.0.1. So there's a lot going on here, a lot of moving pieces, a lot to absorb, but that's a look at how we would do full-blown VRF-aware routing, configuring an MPLS Layer 3 VPN. I hope you found this content useful, and I want to thank you sincerely for watching.